Hey, we got Unit 8, Lesson 2, okay? So today's focus, you guys learned about reference angle and rotation angles yesterday. Today we're talking about the ratios of the angles, and we're also going to talk about the cast rule. Okay, so I kind of told you guys intro with your project and stuff about radians a little bit and about degrees, and understanding that those represent positions around a circle, okay? So if I say 70 degrees, I'm just talking generally here. If I say 70 degrees is your position, that means, well, here's 90, so my position is right there. Okay? What determines how far you go out is what your radius is. For a unit circle, just so you know, it's always a 1, but your radius can change throughout circles, of course. Okay? But your position is determined by that radian measure or that degree measure. Okay? It tells you where you're at. Okay? We're going to talk about that. It's important a little bit. Just want you to understand. We're looking at positions. So when you go through your project, guys, you're going to see it's a ton of Pythagorean theorem. Pythagorean theorem and special triangles build the unit circle. So the idea that a squared plus b squared equals c squared is very important, because actually Pythagorean theorem is used for the an equation of a circle. X squared plus y squared equals r squared. And that's why it's very unique to the unit circle, because here's your x value, right? Your lateral. Here's your y value. Those are your legs. X squared plus y squared equals the radius squared. And so that's the equation of the circle. If you actually want to put a circle in your calculator, just FYI, you would solve for y. I'm just showing you this if you actually want to graph a circle sometime. You would go y, so you'd minus this, and you'd square root that. So you'd say y equals 25 minus x squared. And you put a plus, a positive. You don't have to put a positive there. But then you can do the negative of that. That would graph you a circle with a radius of 5. Square root of 25 is 5, right? Just so you know. Okay? That's just food for thought. That's nothing more. Okay? Does everybody see the relationship with Pythagorean theorem and circles? Yep. Okay, we good? Obviously, r has to be bigger than 0. All that means is that it has to be positive, which we don't have negative radiuses. So, okay. So, sketch the rotation angle in standard position and calculate the exact distance from the origin. Okay, so whenever you see exact, no decimals. Okay, exact means no decimals. Okay, where appropriate, write the answer in the simplest mixed radical form. So it says you have the point negative 5, 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going to be a little bit high here. So it's right there. Okay. It wants to know the point P on terminal arm angle theta, so we're trying to figure out what the exact distance from the origin, which is also the radius. Trying to figure out that distance. How we can do that is, we know what this length is, and we know what this length is. We have a right triangle. This length is 12. This length is negative 5. It's technically 5, but when you square it, it's going to go away either way. So I'm going to go negative 5 squared plus 12 squared. Again, you can put 5. I'm just putting negative just for now. Negative 5 squared plus 12 squared is 169. Square root of r 13 is the distance from the origin for this one. So this is a nice whole number. Okay. Any questions on that one? Yeah. Right. And so we're actually doing x squared y squared equals r squared. We're going to think in terms of this stuff and stuff we're doing with trig, x, y, r. That's what you want to get used to. Okay, so this point, negative 2, negative 6, so we can draw that here. So negative 2, negative 6, 2, 6, 1, 2, 3, 4, 5, 6, so right about there. So again, draw this straight down. There's your triangle that you're going to use. So you're going to do negative 2 squared plus negative 6 squared equals r squared. That's going to be 4 plus 36 equals r squared. We'll say equals 40 equals r squared. We're going to square root the 40. You've got to use our radical stuff from Unit 1. Break that down to 4 times 10. So your simplified answer, they said, in exact form is 2 root 10 for r. R is always going to be positive. It's going to be a distance from the origin. Distance is always positive. Okay? All right. So now we're going to set up the ratios. These are from the ratios you probably remember from Math 10, SOHCAHTOA, right? That's the acronym that's commonly used for remembering your ratios. If you don't know what that stands for, sine is opposite hypotenuse, the O and the H. Cosine is adjacent hypotenuse. Tangent is opposite adjacent for the O and the A. SOHCAHTOA, that's how you can remember. So in regards to this right here, sine ratio for sine theta here, so we would just write simply opposite hypotenuse. And then here we would write adjacent hypotenuse. And then here is opposite adjacent. Just the ones in SOHCAHTOA. And then we're going to talk about writing those with x, y, and r now. Okay. Any questions so far? SOHCAHTOA, remember that? Okay, good. Okay, so here's the next piece that I want to tell you. Let's go ahead and do this first. What is sine theta for this one? Sine theta is opposite over hypotenuse, so y over r. Okay. Cosine is adjacent, x over r. And tangent is y over x. And I want to make a note here for your future and unit circle stuff. Okay, when we're talking about sine around the unit circle or around these coordinates, sine represents the y value. It's associated with y. Especially in the unit circle, because in the unit circle, what I tell you the radius is. I said the radius is 1 in a unit circle. It's okay. So what's y over 1? It's y. So when you're doing the unit circle stuff, when it asks for what sine of pi over 4 is, okay, I'm putting things together here. It's more advanced for you. It wants the y coordinate at pi over 4, okay, because you have an x and y coordinate, right? Okay, just something to think about. So all I want you to get, if you don't get what I'm saying right there, that's fine. But I want you to associate sine with y and cosine with x. Okay, sines with y, cosines with x, because of these ratios. Okay. Questions? Okay. What's that? No? Okay. Let's look at this one. All right, the point 15.8 lies in the terminal arm of theta as shown. Calculate the value of r. Hence, determine the exact values of the primary trig ratios. Okay, so this is 15.8, so that means that this is 15. This is 8. So we want to go 15 squared plus 8 squared to get our r squared. 289. Right, so r is 17. And then it wants us to write the ratios now. We have x, y, and r, so we can write those 3 ratios. So sine theta is what? Good. And then cosine theta and tan theta. Yep. Just plugging in your x, y, r, and the ratios you just wrote above. All right. Okay, a little bit more here, and then we'll get to the cast rule. Okay, so investigating trig ratios for angles between 90 and 360. So we're going to talk about a couple angles here. So consider an angle theta in standard position with the point of 1 root 3 on the terminal arm. Show that the value of theta is 60. So show the value of theta is 60. So how you would do this. All right, so that means that for that point, x is 1 and y is root 3. Okay. So that means that tan theta is root 3 over 1. Does that make sense? Now this is how, if you're solving for an angle or a position, okay, first off, I don't have my calculator up, you guys can do it. Make sure, let's go right now, read the calculator out or share with somebody. Hit mode and change your calculator to degree mode. It's probably in radian. Perfect, leave it there then. Okay. So now as you're in degree mode, we're going to solve for this. So what you do is it's like we want to move the tangent away, right? We want to know what theta is. So what we do is we use the tan inverse button. So you're going to hit second tangent and do tan inverse of root 3, because root 3 over 1 is just root 3. And that's going to kick out 60 for you. And so that's what theta equals. Yeah, so you should put tan inverse of root 3. You should get 60. Yeah? I use tan there because I have y and x. I didn't have r, so I might as well use the stuff I have. You were going to solve to find r now. Yeah. But yes, you could, and then use sine if you rather. That's fine. They will all get the same answer. So if we do 1 squared plus root 3 squared equals 4, square root of 4 is 2, so r is 2 in this case. So that means our values are, for this 1, root 3, and 2. So here's the interesting thing I want you guys to do. This is what I think is pretty neat about trigonometry. What I want you now is, I want you to put sine of 60 in your calculator. Just put sine of 60 and look at see what that decimal is. Okay, whatever that is, just now I want you to go ahead and I want you to take y, root 3, and I want you to divide that by 2. So go root 3 divided by 2. Yes, it's the same thing. Okay, so root 3 over 2 is the same thing as sine 60. Root 3 over 2 is the same thing as sine 60. You'll learn about root 3 over 2 in your project, about it's an actual location. Cosine of 60 is 1 over 2. If you put cosine of 60 in your calculator, you're going to get 1/2. You're going to get 0.5. Tan of 60, we already know that one. It's going to be root 3 over 1. It's going to be root 3. Okay, any questions there? Okay, so now we're going to move to the next quadrant over, and we're going to talk about what happens over here. So the rotation angle in part 1 is reflecting the y-axis. So we're going to reflect that same exact point over the y-axis. Okay, so we took this point here, and we reflected it to there. So it's the same distance, same height. Right, so what changes? It changes from 1 root 3 to negative 1 root 3. So here's the question. We got it from this guy, right? And what was this guy's angle? So then what's this guy's reference angle? 60. And then what's its rotation angle? Good. 120. Okay, if you're missing that. If they're reflected, that means they're going to have the same exact reference angle. 60 less than 180 is 120. That's why they got 120. So now, same exact thing. In your calculator, if you hit sine of 120, what do you get? You probably are going to get the root 3 over 2 again. If you do cosine of 120, what do you get? Oh, that's weird. Why is it negative? We're negative for x now. We're on the left. X is negative on the left side, right? Sine's still up, so sine was still positive. So you get negative 1/2. Okay, and then tan 20 equals y over x. Tangent's going to be negative because it's y over x, so it's negative root 3. Okay? It could be root 3 over negative 1. Okay, so that's quadrant 2. Now we're going to jump to quadrant 3 next. So right now, guys, all we're doing is we've identified a position in the first quadrant, which is fairly easy, and now we're seeing what's changing as we go to each quadrant to develop the cast rule. Cast rule tells you what's positive where. So now we're looking at part 3. We're in quadrant 3. Reflected it again. So we're going to have the exact same reference angle, right? It's still going to be 60. The point now is going to be, they're both negative down here, right? Negative, negative, left and down. So x and y are both negative. What is the rotation angle here? 240. 180 plus the 60, so 240. And then let's look at all these ratios. So it's sine of 240. Well, we know sine in this section is going to be what then? We're down. It's negative. So that means it's going to be negative root 3 over 2. Cosine in this section is going to be, we're left. So it's going to be negative. What about tangent? Why? Right, see, we have y over x that are both negative, so tangent's positive here. Good? Questions? We're going to do the last quadrant next. Keep asking questions. This is very big for understanding of the sections here. All right, so the last fourth quadrant. So the point over here, yep. When you're doing sine of 60 is the y coordinate to the circle. And then when you do x is the x coordinate to the circle. But it's the y coordinate over r. Unit circles in most of the is going to be a 1, so a lot of times it's just y, but it could be over 5 if your radius is 5. But it's the y over r ratio. That's what it is calculating. Okay. All right, so the point here, so they can change now. Now cosine's positive again, but we're still negative for sine. 1 negative root 3. Still a 60 reference angle, so what's that rotation? What is that there? 300, good. Cheaters. Okay, so sine of 300. Sine of 300, is that going to be positive or negative? Negative, good, because we're down. Cosine of 300, negative or positive? Positive. We're to the right now, right? And then tangent, y is negative, x is positive, so it's a negative tangent. So negative root 3. Okay. So the observation you're just making is, if we look at that, in part 1, what was positive? In part 1, everything. And in part 2, what was positive? The sine, part 3. And part 4, cosine. Okay? Keep that in mind. Okay, let's go through this here. All right, let's move up just a little bit more here. Okay, so I just want to do a plus or minus chart here. That's all I want you to do. And so what they're saying is that, so in quadrant 1, y over r, we know this is x over r. We know this is y over x. All of these are positive in this quadrant, so it's going to be, the outcome's going to be positive for all of them, just like you said. Quadrant 2, so I'm going to go through, I'm just going to write all these just to get this out of the way. Okay, so I got all my ratios written down. So now we can say, okay, so here, positive y, positive r, negative x, positive r, positive y, negative x, negative. It's a negative y, positive, negative x over positive, negative over negative, so positive. In the last section here, and then I'll pause the video here so you can write these down. So y over r here is a negative sign, positive. Whoops, that's a negative. Okay, cosine positive, positive, and y is negative, positive. Okay, so just putting out the signs here for that pattern. Okay, so what do we learn from this? We learn from this that sine is positive in which quadrants? 1? Nope. 2. Right? Because let's just number them here. The visual here that's kind of nice is we know sine is up. Right? Top, positive, right? Okay, cosine is positive where? X, where's x positive? The right side. 1 and 4. Right? Tangent was positive where? 1 and 3, because it's that weird one where it's positive here, because the other thing is, and then negative, negative made tangent positive in 3. Sine's negative, then where? The converse is the bottoms. 3 and 4 for sine. And then for cosine would be 2 and 3. And then for tangent would be 2 and 4. Okay, that is the cast rule. So this is your cast rule if you ever want help remembering. You start down here is the hard part. That tells you what's positive where. The cast rule, okay? So cosine's positive here, all is positive here, sine's positive here, tangent's positive here. So that's how you can remember which ratio is positive where. Okay, you also can remember if you know your x and y as well, right? But the cast rule. Okay, let's do some examples of these to figure it out. I'll show you why this is kind of helpful. Any questions on that? Okay. All right, so here we go, guys. Determine without using a technology whether the trigonometric ratios are positive or negative. So that's all you got to do. They just want to know negative or positive. That's it. Where is sine of 340 at? Which quadrant?
4.
What is sine in quadrant 4?
Negative.
Done. It's a negative value down there for sine. So this is the thought process if you're a little behind. 340's right here. Not quite there. 340's right here. That's negative for sine. Sine, that's down. Okay, you said tangent 227. 227's in the third quadrant? Yep, that's positive because tangent's positive in the third. Sine of 88. That's in the all. Positive. Cos of 235. Negative, that's third quadrant. Cos of 308. And tan of 123. Negative. Tan 123 is right there. Tangent's only good in 1 and 3. Okay? All right. So trig ratios of an angle in terms of a reference angle. So now what they're going to do is, and this is the interesting part, the symmetry of unit circles is really neat. Okay? Because if I have a reference angle in the same spot, that cosine's going to be the same value but change sign. So let me say that again. I'll actually draw a little picture here of it. So like if I told you that here, 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 and here, all of those have the same position and the same reference angle. Let's just say it's 30. Okay? What that means is all of them will have the same y, but just different signs. So if the y happened to, let's just make one up. Let's say my y is 2 here for sine. Then this is 2. This is negative 2, negative 2. Okay? And so that's what the idea is, that when you look at these reference angles, if it's a positive value or negative value. So this is what they're talking about.
What would be different about them?
What would be different? Just the sign. So like my point is let's go a step further here, Joel. So here's 30. This is 30, and like as a rotation. This is 150. This is 210, and this is 330. On this example that I just made up, if I said, what is sine of 150? You would put positive. It's a positive 2. What is sine at 330? Negative 2. Okay, and so knowing this negative. And so what they're saying is, how can I write it, though, with only reference angles? So, for example, cos of 30 is 2, right? Or sine of 30, sorry. Sine of 30 is 2 on my example. We get that, right? So then if I said, write sine of 210, sine of 30, right? Sine of 210 is sine of 30, but with a positive or negative. So the confusing part here is that if I do sine if I do sine of 30, okay, that's the reference angle, right? All of these have a reference angle of 30. So if I do sine of 30 for all of them, that same answer will kick out. But if I'm asking for 210, if I want to write it as a sine of 30, what do I have to change? I have to write it as a negative, because I know that's a negative value down there. Okay, so we're going to do some of those now. That's what they're talking about right here. Okay, but let's just do some examples that actually have numbers here. Okay, so what they want, you got to do two things. Okay, two things. Find the reference angle and write whether it's positive or negative. That's two things you're doing. So what's the reference angle of 140? 40. So do you guys understand? Yeah. Okay, so we write it as sine 40. And now you ask yourself, is sine at 140 positive or negative? Positive. It's up here, right? So I'm up. So you just leave it sine 40. The point is sine 40 and sine 140 is the same value. Okay? So tan 323. What's that reference angle? 37. Good. Is tangent negative or positive in the fourth quadrant? Put a negative in front. Now you have the value. Cos of 165. 15. Is cosine positive or negative in the second quadrant? Sine of 287. 73. Is sine positive or negative in the fourth quadrant? Negative. Okay. Cos of 308. 52. Positive. Just leave it cos 52. Now this is the one here. I can show you this one really good. Cos of 2, if you're not understanding completely what we're doing, check this out. So if 52 is here and 308 is here, what do you notice about their x values? They're the same. So you're just writing it the same. You're writing it as cos 52 because it's equal to cos 308. They're the same value. What's that? All of those are the same? Or what do you say? Yeah. Same y value, sines y. So like an illustration of this one, Parker, would be this. Sine 40 and sine 140, see they're the same y value. Yeah. And so the converse is this. Here, I'll show you again. We'll just kind of go off the grid here. 37's here for tangent, right? Well, tangent's not x or y. Let's not do that. Tangent's a ratio, so we won't use this as an example. Let's use this cosine here. Cosine 165. Cosine 165 is right there, and cosine 15 is here. Now, these values here, that value and this value are the same, just positive and negative. And so that's all we're doing. We're writing them as the positive and putting a negative in front if we need to. Okay, and the last one here, tan 199, that's 18, right? Or 19, I mean. So is that positive or negative? We're down here, right? So positive. Tangent's positive in the third quadrant. Okay. All right, so that's it for the examples. To close it out here, patterns and trig ratios. Okay, here's your 180, your 360 pluses. If you're wondering, this is just kind of what we were just doing, but you guys have a pretty good understanding of it. It kind of tells you what to expect for when what's negative, but I prefer just to use the cast rule. That's the actual setup. So like if sine is 180 minus x, it's going to be a positive sign. If cosine is 180 minus x, it's going to be a negative, etc. So, but yeah, that's it.